Hello friends, today we are going to see about Ospf. It is really an important skill to know more about static routing. So if you know much about static routing, we can use static routes for routes to speak from one router to another, but it doesn't make sense when you come for a large network, when you are designing a large network and you need to configure static routes for reachability for every single network. That doesn't make sense. But if we have a few static routes, like when we have a few default routes in certain areas, it's fine. So most of the time, we are going to have routers to dynamically learn how to forward packets to remote networks using some type of a dynamic routing protocol. So what we are going to discuss in this video is about the dynamic routing protocol. And we are trying to what we are going to try to explain, like how we are going to start is, let's take we are in the United States of America and we are going to travel using a vehicle. Maybe you can use a car, or we are going to use to from United States of America we are going to use a car to travel. So there are two paths that we have. So there is a path A and there is a path B, and we have to reach our destination. So in the right hand side we have some destination, we need to reach there, we need to try to get there. So let's imagine that we are trying to travel using a vehicle as a car. We have the path on the north side, we have a path on the other side as well. So which path we should take in order to reach the destination in the shortest way. But we may not know, like every time, like how it is go taking any path that you want. It doesn't matter, but it we need to reach the place in the shortest time. But if you want to get to this destination, there is definitely two options in order to go for the rest of the journey. There is one path A and path B. So now we are going to take, so the every oval shapes things, oval shapes A, B, E, B, D, F. So those are the different you can say that's a C, A, B, C, D, E, and F. So those are the different toll booths which are there in between before you reach the destination from the place. For this different toll, you have to cross all these toll booths before to cross the destination. So in various countries, toll booths have different names, but you're on a road, you have to stop, you have to pay a little fee to continue on the road, and these are the representing toll booths. And let's put on more and let me go. So okay, so these are the number of toll booths. So if you want to cross in each toll booth, if you want to cross toll booth B, the cost is 3. If you want to cross toll booth D is 8, and the cross booth F it is 7. So to the final destination, which path we should take, whether we need to take the path A or the path B. Now we may think like okay, let's say like is the cost everything is the same. I would agree, if the cost is both the same, we can take either A or B. But if the tolls were different at each steps along the journey, it would matter if we are concerned about cost. So give us more information which path we should choose. Let's imagine like the toll number A is having a cost, a total cost is $2, and the toll booth number B is $10, toll booth number E is $7. So toll booth C is $10, B is $3, D is $8, F is $7. So these are the different costs in each tolls. So now assuming all the roads are equally good, so which of these two paths should we take if we are concerned about the cost we pay for the toll? What are the best value of money that we are going to invest here in order to reach the destination? And the solution for that, it could be is like if we can add all the cost and see that which is the best cost. So for path A, so we have like 2 plus 10 plus 17, which gives a total of a $19. So the other one, the core path number B, if you take path number B, it's 8 plus 3, 8, 9, 10, 11 plus and 7. So it is 18. The cost is $18. So the path B has a lower cost. If we are being cost conscious, we should go ahead and choose this path because it is more cost effective on a better value, or it's a better path. So let's take what we know and apply to this. Let's take say that the A, B, C, E, A, C, E, B, D, F are the routers. So each of them are routers, and they are running a dynamic routing protocol. So if we run a dynamic routing protocol on all each of these routers, that allows these routers to talk to each other and communicate information. Once we do so, we see that when we learn from the router 1 to A to router E, like we have, you don't need to manually configure static routes. We can dynamically learn information how to reach remote networks like how to reach how to reach F using a dynamic routing protocol. So not every dynamic routing protocol is created equal. There are two. How dynamic protocols is operated? One of them is like we have some distance vector routing protocol. If you think about distance vectoring protocol, so what are the distance to a given destination, the vector, which direction should we go? So for me it's like so distance and which, how much distance and which direction we should go, that's the distance vector. And one of the old dynamic routing protocols is the distance vector routing protocol. There's a call called RIP. So RIP is routing information protocol, and people who are still using this protocol, they use the version 2 for a lot of good reasons, as it's a distance vector routing protocol. But it's not too smart because the distance vector router protocol, basically it doesn't take into consideration the actual cost of each of the links as we go from the source to the destination. Instead it's just the hop count. So in distance vector routing protocol, the RIP, to go from one part to another, in RIP perspective, it would say a different way in which it calculates the cost. They refer to as the hop count. So each router being a hop in the path, for a path B, it would be like, this is the cost for RIP. Would say the path B is a hop count of 3, and as a result, like if your path A is also hop count of 3, so like it says like both are of the equal path, which in fact is not equal to the other. So one is better, but distance vector routing protocol don't take into consideration the factor of cost or how effective a path is. They are just looking at the hop count in the example of RIP. So the next question of the category over here is a lot better than the distance vector routing protocol. And the family that we are going to look after here is called a link state routing protocol. So a popular example of the link state routing protocol is the Ospf. So the Ospf is used for routing for IPv4 packets, and it is referred to as a version 2. So if you use Ospf by itself or Ospf version 2, they are referring to routing for IPv4. If you're looking at IPv6, they call this Ospf as Ospf version 3. So the next thing is like how in the world, like how is this Ospf operate? So it's an example of a link state routing protocol which does better in making decisions than the competitors as the distance vector routing protocol. The answer to this information you can say is we would train all the routers to run their Ospf routing protocol. They would start communicating with other neighbors that they are adjacent to. These routers would start talking with each other directly, but in addition, they would create what's called a link state agency. It's called an LSA. The LSA stands for link state advertisement. And in that link state advertisement are pretty simple. It's like the link state advertisement is like how we chat with each other on the phone. So about if you take about the F router, how we are talking about the router. So if you if you want to know more about like router E or router number EF, we'll say okay, this interface is connected to the network. Let's say like ENF is connected to 10.9.0.0, and over the interface it's connected to 10.7.0.0 with a 24-bit mask. So it says that the network would be the more details would be the cost. So some of the information in the link state advertisement. So the basically like the best in the way in order to for this routing to happen is the best the dynamic routing protocol is the OSPF. Here each router generate the link state advertisements in order to connect to the network. The information can be forwarded over the whole network, so every router has a copy of the information from all other routers. That's the main thing. To I'm repeating again, like every router will have a copy or has information from all other routers. The router can piece together like it's like a kind of a puzzle. We can get together because every router has information of all other router, and that gives routers the ability to say that okay, path A, the cost is looking at my nose. Okay, it says 19 is my cost here. On path B it says cost is 18. So it does give the routers the ability to collect all that information. They take all those LSAs, they put them into what is called a link state database. So link state database is a collection of the LSA information that each router can figure out what path, what is the best path is. If you take a topology, so going back to if you need to reach the end of router, the every router will be generating their link state advertisement with information about what networks they are connected to and what cost it is. Then a router like the first router can take all information of this was a router, like we call this router. Like if this is a router that has all data from all routers and all those link state advertisements, then we know for one router to go to the another router, what are the costs. So like from A to if you want for router A, the cost from the United States America to go to A, the cost is 2. And for to go to B, that is for B, the router's cost direction is 10, and to for router E, the cost direction, the cost in this direction, that its cost is 7. So the router can add up those and get the cost. This is the cost 19 for the path A. Then it can also be aware because of the LSAs all the costs on the bottom path and add them up, and each router with all the data is going to make a decision. So it's going to choose the shortest path first, and that's why the routing protocol is called open shortest path first. So every router in the area has information about all other routers in that same area, and they can make an intelligent calculation on the best path, which includes the cost. And as a result, we can choose better paths opposed to dynamic routing protocols. So where cost and other details about link in that path are not considered. So here are three basic takeaways is like if we have a lot of networks doing static routes for everything, it's too tedious, too painful and too hard. So if things change, so we have to go back and revisit it. So we have to if something changes, we have to go back and change all the static routes, everything. So we use something called a dynamic routing protocol, and there are two categories of dynamic routing protocol. One is something called a distance vector routing protocol, which is not very smart. It's a basic idea, but doesn't take into, because it takes into consideration the hop count, but doesn't take into consideration the cost. So like with the RIP version 2, it's just counting the number of hops, the number of routers between here and there, and that's it. And now in contrast to that, the routing, the family of dynamic routing protocols called the link state routing protocol. The best example is the OSPF. With OSPF, each of the router is advertising the details and the costs about the networks they are directly connected to. So all that information is forwarded to all other routers in that area. So each router has a link state database, basically a collection of that information, and then it starts deciding, just like we did at the beginning of the video, like which is the best path. So it costs 2 here, it costs 10, 7, it costs 3 here, it costs 8 here, it costs 7 here. So open shortest path first is a popular dynamic routing protocol that is a link state, and it happens to be like a most important protocol. So we'll have a closer look in how like interworkings of the details of the OSPF, and I hope like you'll have a better idea like how static routes now differ from the dynamic routing protocols as distance vector or RIP, and link state protocols as OSPF, which do a better work by calculating the cost and giving a shortest path first. Hope this video is useful. Like I would have published this most of these ideas in of one of the books as well. So if you wish to have a look on that, you can have a look on it on the basics of telecom as well as the networking basics book. So you can have a look on it. Okay, see you until if you wish to have more updates on the upcoming videos that I'm gonna put like on OSP or the different protocols, different dynamic routing protocols. Just subscribe to the video and probably like we'll catch up in another video. Thank you. See ya.